Hey everyone, this is Joseph Anderson, CEO and founder of Connex. Years ago, I watched my mother lose her job after developing carpal tunnel syndrome from repetitive data entry work. She had surgery and was later let go from her job in her late 20s. That moment really struck me. That I remember thinking there has to be a better way. We were put on this earth for more than just manual data entry. And that's what inspired me to build Connex, a tool that automates e-commerce operations and helps businesses eliminate the kind of tedious, manual work that just burns people out. Today we're joined by Sharon, a leading voice in engineering excellence, data, AI, and inclusive leadership. Sharon is a senior director of software engineering with over 15 years of experience in leading high-profile engineering and data teams. And with degrees from MIT and UMass Amherst, her career spans industries, spanning from medical imaging to audio technology, telematics, and even fintech, building scalable platforms and innovative products at the intersection of software and data. Sharon is passionate about creating engineering cultures where people grow, teams thrive, and innovation flourishes. Based in Boston, she brings the same curiosity and creativity to her personal life, whether she's traveling, painting on oils, or kayaking along the Cape. Sharon, let's kick us off our first question. Tell me a little bit about your background and experience.
Well, thanks for that great introduction, Joe, and thanks for the story. It's very inspiring. I've been fascinated by technology since childhood. As a youngster, I taught myself to program in BASIC, and I became totally hooked on software engineering. And that interest was what led me to go to MIT and get a computer engineering degree and then a master's from UMass Amherst. As you said, my career spans a broad range of topics, but from medical and audio and voice cognition. But one of the things I find most rewarding about leadership and about technology now is the people and the great impact you can have by providing the right environment. My approach to providing that environment is to use a combination of emotionally intelligent leadership, focus on engineering excellence, which is a topic we'll delve into in more detail here, and having a strong strategic vision. I find having the combination of all of those things really creates a high-performing team and a great environment to work in. And these principles have guided me in leading organizations of over 100 engineers and data scientists at some different companies ranging from startups to large fintechs, and in delivering large-scale, data-driven solutions, and many of which have resulted in patents that I've personally contributed to.
Tell me about some of the patents that you've contributed to. It sounds like you've dealt with some really big teams. Is there anything that stands out?
Some fun stuff that I worked on earlier in my career when I focused on really honing my technical skills was in ultrasound imaging, where I worked on a way to calculate the amount of blood that your heart pumps during each heartbeat, which is used to diagnose various conditions. And that was really, really interesting and impactful to work on. Later on in my career, I had a few different patents around voice cognition and noise suppression, and it was especially one where we're using different combinations of noise suppression techniques to get an even higher environment. I don't want to dive too deeply into the details here, but voice cognition is the area that really led me towards machine learning and AI and big data. And so that was one of the turning points that in my career, going from the image processing and the signal processing to more modern, larger, big data, just kind of diving off into that cliff of where we are right now in terms of machine learning and AI to do a lot of these computations where you would have back in the day done a low pass filter. Right now you train a model to give you some similar insights.
I've been using ChatGPT and Copilot to write and even rewrite some of the code inside of our Connex software, and it's allowing my staff to work faster. I spent an hour and a half writing code that normally would have taken me over 8 hours because a computer could figure it out for you. So the generative AI has definitely come a long way. Wish I had it 10 years ago. Looking back, what are some of the most significant moments or pivotal transitions in your career that have brought you to the current role?
I like to think about my career in 3 phases. The first was honing my technical skills, and we talked a little bit about some of the patents, understanding software development, understanding how to write really great software in a highly regulated environment like medical or bank. And that was great. But at a certain point, I started to realize that what got me there couldn't get me further. So What Got You Here Can't Get You There is actually a great book. And I wanted to have a larger impact. And you can only do so much as an individual contributor. And so I got interested in leading teams and figuring out how to work with a team of people with different strengths and different capabilities, do larger and more impactful projects. And so at that point, I was working at Bose Corporation, and they had a lot of excellent management training, which allowed me to learn things like situational leadership, where you modify your approach based on the skill level of the person that you're working with. So lots of really great insights there, and became a good people leader. And then after working on that for a while, I decided, wow, I really want to get involved in strategy and in leading a company in a particular direction. And I went to work in Silicon Valley for a startup within a big company. And we were developing the machine learning-based noise suppression and the voice cognition tools, which were sold to some pretty large household name companies in that area. And I really started getting a lot of experience in talking to customers and working with product teams and in presenting strategies to the C-level. And so those were, if I divide my career into those three parts, individual contributor, team builder, people leader, and then strategist and large team enabler, there were definitely some pivot points where I took a step back and said, I want to have more impact. I want to do bigger and better things.
Yeah, it sounds like you really help those engineering teams and AI do bigger and better things by, doing the strategy. How can engineering leaders effectively leverage AI tools to support team productivity, enhance decision making, all while avoiding the pitfall of micromanaging developers?
Yeah, that's a great question. There's a lot of temptation to get into the pitfall of micromanaging. And I would say that AI is a fantastic tool. If you use it, as you said before, Copilot is phenomenal to be kind of your coding buddy. And that's a way that I think a lot of people are using it. You also can use AI to do things like process mapping or refining your JIRA stories, helping you figure out requirements. So there's a way in which smart documentation becomes much, much easier. Documentation, better design documents become much easier to create if you have a tool like ChatGPT or Copilot or Gemini. I find that my teams, I encourage them to use Copilot for automated code reviews, catch a lot of stuff, and to create better documentation and to create acceptance tests and unit tests. So there's a lot of different ways in which AI can automate stuff which would be more mundane tasks that lots of engineers really dread writing a design document. They have the design in their head, but they dread
even
writing
for
the document.
The AI, like using it to write unit tests to make sure that software actually works when we publish it. I think those are some really great points. And speaking of software, you mentioned you have something called a DORA metrics, DORA. And
Yes.
so why are they so crucial to modern engineering teams?
DORA metrics, DORA stands for the DevOps Research and Assessment Team, which was something that Google did to try to figure out what differentiated high-performing teams from the average teams. And it boils down to really, surprisingly, four things. The first is deployment frequency, which is how often you release to production. The second is the lead time for changes, how long does it take you to implement and deploy a feature. The third metric is the change failure rate, which is when you deploy, how many times is there an issue? And fourth is the time to restore service. So if I have an issue, how quickly can I roll back a change? And those four metrics are really, they're outcome oriented. They focus on the flow of value. They focus on stability and team resilience. And it's probably the strongest indicator of a high-performing team. And I read the book Accelerate. It must have been 4 or 5 years ago, and it incredibly changed how I viewed software engineering because, wow, The numbers, the research was very compelling on these fronts.
But teams that deploy to production more often, they have more lead time on projects. If you gave a team 2 to 3 weeks, they would do better than a team with just 1 week. They have more notice, more time to plan. Is that the idea?
I think maybe I might have misspoke or it didn't land right, but the shorter the lead time, the more effective the team. And the reason for that is when you do a big bang, when you do a huge change, there's so many things that could go wrong. I spend 2 months developing a feature and then I merge it immediately, while other teams are also operating that code base. You end up with a nightmare of merging, and you end up with a huge amount of testing, and so it's a little bit more waterfall because you have to go through a very large regression test in order to prove out that large change. With smaller changes, you can test with much less risk.
We've had that challenge too. We've had this summer of 2025, we were doing a big upgrade on our Connex software. We had to change something like 350 files. It became very difficult to test it. But this week we had to change to maybe one file with a couple lines of code. We were able to deploy within 24 hours. So I see what you're saying. Can you provide some concrete examples of how DORA metrics could lead to tangible time savings or cost reductions in real-world projects, organizations, drawing from general industry insights?
Yeah, so we talked a bit about how it's less risky to do smaller changes. The other thing that's really great about using small batches and small lead times is that you can build value and get feedback from your user community, from your business partners, from the folks actually using the software, and you can adapt and make changes. It's much more agile. So that's one concrete example. A second concrete example is an increase in uptime or decrease in downtime, depending how you want to look at it. So say I did a deployment and it wreaked havoc somewhere. If I've done my automated deployment pipeline correctly, I can roll that back, and you will have a very, very limited effect even from a significant bug. So it's that rollback. In order to do automated deployments in the way that we've been talking about it, you have to have automated testing suites. If my testing suites are completely automated, I don't have manual testing. I can get through my test cycles much more quickly. Reduce development time because, hey, I can make a change and test with much less cost on the testing side. I can get feedback from my users and create more product value, and I can limit any impact of a defect or a bug that somehow gets into production.
Yes, I agree. When you do changes in smaller increments, it's easier to roll them back, whereas when you publish one big change, it's more difficult to roll it back. We've had that issue with Connex where we've done a big change. There was an issue, we rolled it back, and then other people's accounts broke, and that's been a challenge. So what's your perspective on how companies can effectively avoid the trap of turning DORA metrics into vanity numbers or a tool for blame?
That's a big concern that amongst engineers. Everybody worries that, hey, there's another metric, I'm going to be reviewed on this during performance time. And so my answer to that is that metrics are signposts. You should never use the raw value of a metric. Say team has a really long lead time, there's an anomaly. And so if you dig into that, a manager or leader should say, hey, there's a metric I don't think is great. What's the cause behind it? And it's often you might find that, hey, they're having trouble getting requirements, or hey, things are murky, or their interactions with other teams are some smoothing out or some work on it. So the metric should always be a diagnostic tool, not a performance measurement, because what you're trying to get to is a high-performing team that feels good about what they're doing and is inspired by the work. And so saying, Sharon, your lead time wasn't where it was supposed to be is one thing, or saying, hey, Sharon, it took 3 weeks to implement that feature. What happened? And I can say, well, I couldn't get the requirements, or I was working, things were murky, or whatever the reason might be. But you as a leader need to take those metrics and use them to figure out how you can make positive change. So that's how I frame it. It shouldn't show up on your performance review. It should be your dashboard, right, to how to make things better.
Yes, here at Connex, we were actually releasing too quickly, and I wanted the team to release every 2 weeks. I gave them adequate time to run a full test before deploying, and we've had fewer instances of downtime. And then we may do little bug fixes, like a file or two, like during the week, but they're not, massive changes. We try to actually hold back everything for the 2 weeks unless there's a lot of downtime. So I see your point about waterfalls and just trying to do things in smaller increments.
Yeah, and sometimes you do want to have releases on the slower cadence into production. But the thing about having merging often and deploying often, it can be into your pre-prod. We're trying not to have a lot of large changes needing to be all tested at once. We're trying to not have large changes needing to be merged all at once. So as long as you're merging out to your pre-prod, I think that you get a lot of the same kind of benefits.
Yeah, and the benefit of a smaller change, if it doesn't work out, you can more quickly roll it back. So it's not good to make a lot of big changes like that on a frequent basis. So looking ahead, do you envision AI continuing to evolve the role of engineering leaders and reshape the understanding of developer performance and team collaboration?
It already has. The changes are already happening now. I think it's going to continue to accelerate. We're going to be, as engineers, using these tools to, as I said before, write code faster, write unit tests faster, write probably even component. And we're going to have better documentation and a better ability to comprehend the documentation, because you can create your own GPT or GEM, depending what tool you're using, for a module or a subsystem. It's just going to accelerate. And I also see that in the future, AI is going to fundamentally reshape the role of engineering leaders into more of a merging with product, because there's always going to be a need for humans to figure out what to do, what to build. I have a product need. Well, what is the user's pain point? Or what am I really trying to build? And when engineers get better and better at the prompt engineering, we're going to automate a lot of the mundane aspects, like writing a module or writing a set of unit tests. That's going to become easier and easier. So then the skill set is really going to be in how to architect, how to build, how to figure out how to test, what to test, and that kind of higher level thinking. So that's why I say I feel that some of the levels of product and engineering will merge a bit, because right now product is focused on the what, and the engineering is focused on the how. But if the how becomes easier, then those boundaries get a little bit more permeable.
Yes, I agree. I think I use Copilot at my job to figure out lower level problems. How do I do this? Like, here's a code, put it in, make this code, look better, create code for this test. I did this on a Saturday, and within 90 minutes, it did a great amount of work for me that would have taken a great amount of time. I think the lower level work will be done by AI, and the high level work of, like, how should we solve this kind of problem with a more structural, higher level thinking, I think will still be done by people. Finally, as we wrap up, what are your closing thoughts on striking the right balance in using AI management for software engineers and ensuring that we don't lose that essential human-to-human connection and effective communication?
I firmly believe that we need to strike a balance of AI and that wonderful human brain, that wonderful human thought process. AI can augment our capabilities, but it doesn't replace what we can do. As we talked about before, what are we going to build? How are we going to solve the problem? What are the user's pain points? How do we architect this? How do we leverage latest technology? Is going to remain the realm of human creativity. And AI will, of course, get better at building the bricks, but we're going to be designing the houses and the cities. And so realizing that you can't just press a button and have AI spit out what you want in terms of a large complex system is key. I think that a lot of people who aren't knowledgeable about the details think that, well, sure, AI is going to do everything, but there's limits. There's limits to even something as amazing as some of the capabilities that we've seen. And so that creativity, that working together, if you work with Gemini or ChatGPT, it's really kind of having your buddy next to you who can do the
I may ask you like, hey, this code isn't working, and I'll put it in there. Tell me, or this error. I'm writing the code and I ran into this error message. Go in and fix it. It's good at those sort of go to those sort of things, or give me code that does this. But I don't think it's it wouldn't take the Connex Commerce software and build it from scratch. I mean, it's just too complex for it to understand, but it may be helpful in maybe like some structural issues, like take this code, it's got, 1,500 lines, and break it into separate files and make it easier to read. Based on, I did this actually with the Connex Commerce product. I had a file with 1,000 lines, and I said, I want you to break it into separate files. One for working with products, one for working with lists and customers and orders. And it split it out for me, and it made my code a lot easier to test and read. So I definitely agree that I think the balance, like you said, people don't understand that it can't do everything, but it can do the lower level functions. So that's a...
Yeah, I agree with you. That's totally...
Yeah, definitely a good point. So that'll be a wrap for today's episode of the Connex Podcast. And I want to give a huge thanks to Sharon for sharing her expertise on scaling modern tech organizations with both AI innovation and inclusive leadership. If this episode has sparked new ideas about how to use new tools like Copilot, ChatGPT, or Gemini in your own workflows, or how to lead high-performing, human-centered teams through transformation, follow Sharon on LinkedIn to keep learning from her. And if you're looking for a way to eliminate manual data entry, streamline e-commerce operations, and scale without the burnout, visit connexecommerce.com to see how Connex can help. Be sure to subscribe, leave us a review, and share this episode with a founder, engineer, or leader in your network who's building the future of tech, one smart system at a time. Until next time.
Thanks, Joe.
Sure. Thank you for being on the podcast. Brooklyn, are you there? Okay, so that's a wrap.